And I'm sure if you're interested in cars, we hear a lot about them when we're on meetings together, and I know absolutely nothing about cars, so I can't tell you any of the fun facts he's shared in the past. So
I need to be his friend so I can get my car fixed. I had to replace a light bulb today, and it was like impossible.
I'm happy to.
A lot of our meetings become very car-centric, and unfortunately, I do not contribute to anything that they're talking about on the call. And I also tone it out. So with that, I'm going to let Motaz take it away. Stop sharing.
Okay, thank you, Jenny. Run presentation. So I'm trying to share my screen now. Can you hear me well?
Yeah, we can hear you just fine.
Okay.
I'm not seeing your screen yet. So, Bo, did you make Motaz a presenter?
Yeah, it tells me how to disable participant screen sharing, so I can't share my screen.
Let me see if I can do it.
I just did, sorry.
Okay, perfect.
Yeah, thank you. Okay. Can you see my screen now?
Still can't see it. Are you
No.
maybe clicking the wrong one?
What about now?
Oh, here we go. Here we go. All right, we
Okay.
have it.
Yeah, it's been a while since I used Zoom for meetings, always using Teams. Okay. So today I will give a brief presentation on the Power Letter app, one that we developed in CTSRC for the signals team in Connecticut Department of Transportation. And I'm going to focus on the FME workflow, how we used it to facilitate the process of the application and cover some of the shortcomings of the app. And I will start by giving a short overview of what is the Power Letter app and how it works. And then I will go to the Survey 123, the ArcGIS Survey 123 app, and how it works and how it helps automate the process of the Power Letter. And then I will go through the FME workflow and discuss how, and in a high-level overview, how it works and how it's used by the Power Letter app to automate the process. So at the beginning, the current process starts by some modification or updates that occur on intersection regarding some equipment, like some power-consuming equipment, like a traffic signal or detection load camera or other power-consuming equipment. And a field worker or engineer sends a as-built document to the CTDOT, which the traffic signals team break this down to power wattages and apply some formulas to estimate the power consumption rates on that intersection. Then a formal Power Letter report is sent to the power supplier company and the customer who will be billed with such wattage rates. This is the final product of the process, a formal report that contains information about the intersection, the traffic lights, the detection load cameras, all the wattage values and the formulas of how they were calculated, some information about the customer and the power supplying company. And all this information needs to be correctly filled. And the current system automates this process, beginning with the data collection and ending with this Power Letter generation and distribution. So the workflow is applied or facilitated using three interfacing ArcGIS apps: the Survey 123 application, the operations dashboard, and the feature reports. The CTDOT traffic signals team and the field workers engineers should be able to use all these three apps to collect intersection information and to view previously submitted records and edit existing records, and to automatically generate feature reports using the feature reports tool. And all this information is fed to our ArcSDE database for storage and retrieval. And what I'm focusing on today is the survey app, which will be employing the FME workflow or the FME server to automate emailing process. So whenever a survey 1 to 3 submission is done, this can mean one of three things. A new power letter was submitted by a field worker or engineer, or an existing power letter was reviewed and edited by the traffic signals team. And thirdly, it can be a final approval on the power letter, which should be followed by a distribution for the power letter to the customer and the power supply company, which is currently done automatically through the FME workflow. So these notifications, once a power letter is submitted, we need to notify the engineers that a new power letter was submitted and provide appropriate links. Let me get a pointer. Yep. So notify the engineers that a new power letter was submitted and provide some links to the dashboard or the feature report generation tool that facilitates the process and prevent them from going through multiple pages and searching for the latest power letter that was generated and opening all these tools which consumes a lot of time. So we need to generate a set of notifications and send and email them to the engineers or to the applicant of power letter with proper information, proper links, and sometimes with attachments. And we have, So this is a sample email of the current emails that are automatically generated by the FME workflow. For example, this is a notification for a new submission for power letter, and a link is attached that directly goes to the operations dashboard, and from there, the engineer can edit the power letter or create a report. The third link is the third email is another type that's distributed to the customers and to the power suppliers. It tells them that the information of the intersection, and there will be an attachment to this email that has a PDF format of the final formal power letter report. So we need to auto-generate different kinds of email with different body and titles and attachments. So we have now 4 kinds of email that we need to generate after submission: a new submission email, a review notification email, a failed email notification because of some lack of information, or that because the applicant didn't provide correct information on the power letter. So we need to notify the team with that. And finally, the power letter itself, which will be distributed upon approval. Now, these emails or these notifications can be handled by the Survey 1 to 3 app, the ArcGIS Survey 1 to 3 app. So we opted for the FME server to handle this kind of process. And to understand how this works, I will show how the submission process works on the Survey 1 to 3 app itself. So the Survey 1 to 3, once submitted, it sends a JSON file that contains all question names with values submitted for that question. And these values are broken down on the ArcGIS server and stored to the ArcSDE database. So that's how it normally works. We added FME webhook to use a copy of this same JSON payload or this JSON file that can be also broken down by the FME workflow or FME server. And from there, it can do different tests on the attribute values to decide which email will be sent and what's the content, what's the title, what's the CC list, what's the to list for that email. So this is a logic diagram or flowchart that shows the different tests that we need to check on the answers of a submitted survey. For example, the metered values, whether the intersection is metered or not, whether the power letter status is reviewed or not, and other attribute values of the submitted power letter, which will decide which email will be sent eventually to, and to whom will it be sent. So all this is to decide what will be in the email body, title, the CC list, and the to list, and whether there will be attachments or not. Now, this is the FME overview of the FME, the whole FME workflows that applies this process. Usually, the FME workflow has like a data stream that goes from one direction to the other direction. So here we are going from left to right. We have the submitted JSON payload at the beginning of the data stream, and we break down this data eventually till we send the email at the end of the workflow. So this part at the beginning is designed to read and break down the JSON payload to a tabular format or attributes format. Then this second part looks up this submission and reads the attachments, convert it to the PDF format, and adds it to this data stream. This third part checks for the power letter status and branch out based on the answers for some attributes to go to the appropriate email. And finally, this part has some emailer transformers that defines the correct body, title, CC list for the email that we want to send out. And I will go briefly on each part of this workflow. So this first part here, as I said, it breaks down the JSON payload. It uses a JSON flattener and JSON fragmenter. The fragmenter picks up the update node of the JSON payload, and the flattener flattened this node to it converted it from a multi-level JSON file to a one-level JSON file. And then the feature merges whichever comes from this transformer, whether it was an update JSON payload or a new submission JSON payload. So the second part, this looks up the attachment using the object ID or the global ID and converts it to PDF format. I can't go over all these transformer, but I will briefly describe some of these, like the temp path creator here. This creates a temporary path for the attachments that were read from the database. And there is this feature writer that writes the attachment into a PDF format. The feature reader uses the global ID and finds the correct attachments. And finally, we need this process to add the attachment file to the data stream of the workflow. So the third part here is, and it's an important one. It applies some of the logic that we seen before on in the previous slide. It asks whether the submitted power letter is reviewed or is pending, or if it's set to edits required. These are different values for the power letter status attribute. And based off the value, it can branch out to the correct email. On this column here, this is a set of attribute manager transformers that sets the right to list and CC list based on the answer of previous attributes or questions. And finally, this part, it creates it uses emailer transformers to create email body, to list, CC list based on the answers of the previous transformers. And this final part on the right here, it uses attribute writer or feature writer to update the database. And in this first one, it tells the database that it sets attribute that shows that the power letter was sent, because this email A is related to the power letter distribution process. So we need to write to the database and tell the dashboard or whoever will edit the power letter that the power letter was sent. And finally, this is an auxiliary database that will be updated after the power letter is sent for record keeping. This is an overview of how the workflow works. And I just wanted to say that the majority of these attributes or the majority of these transformers are either attribute managers or attribute removers. We extensively also use this tester transformer to test different conditions on the values of power letter attributes. A closer look of some of these transformers. So this, for example, a transformer was used to, this is an attribute manager transformer. It was used to create the to list and CC list, or in other words, prepare the to list and CC list for the upstream data. And if we look closely here, in this attribute manager, we keep all the attributes as is, but we add more attribute values here with the emails for the to list and the CC list. Every email we need to add the to list, I labeled it with a T letter. The CC list emails, I labeled it with a C letter. So all these data are exposed to the next transformer, which will combine these attributes or choose between them based on the answers of some other attributes. Another transformer, this is a tester transformer. It tested the value of the power letter status. This is the attribute name, which was coming from the JSON payload. And we are testing the value, whether it's reviewed or not. And we are testing it for against other values also, but this is just for example. And this is an example for a tester tester transformer. And yeah, that will be all for today. And we'll be happy to have any questions. Thank you.
All right, thank you. And this is Eric. That was a great, great presentation. So, if you have any questions? I was just looking at the chat to see if anyone mentioned anything. Not yet. Feel free to unmute yourself and ask any questions.
Okay, thank you.
Sure, I have a question. Was that I think could you explain a little bit more about how the FME is triggered? Because it's through a webhook, and that aspect, how it is triggered. Then another question is relating to it from one of your architecture diagram that you have different ASRI stacks involved, application involved. And in that diagram, in that particular slide, I don't know if you can go back to that particular slide. I have a question regarding, yeah, I think that the one prior to, go back one going back, I think maybe, yeah, I think, yeah, I think I-10, slide number 10. Slide number 10. Could you go to 10? Yeah, okay. So you mentioned there's a webhook, and it might be more interesting. I'd be interested, you can show us the webhook relating to that. Yeah, so how it's called. The other thing is, over here, essentially your workflow bifurcates, right? And one use the webhook to call this FME process to issue email. The other from the story 1 to 3 and goes to the ArcGIS database. I was concerned a bit, what if the message, the hook started, however, due to some other glitches, system errors or data errors, the data was not actually written to the ArcGIS database. Do you have anything to get confirmed the data is actually consistent from the data sends over to FME versus data actually being written, being confirmed and validated, written to database being in a consistent state. So essentially, I have these two questions. Thank you.
Yeah, thank you. Sure. I worked a lot on designing the workflow. I haven't worked on the deployment process, but I can answer some of your questions. So, regarding the webhook process, we rely on that the webhook always triggered after the submission, after the successful submission of the survey 1 to 3. So after the data is written, the webhook, the webhook is triggered, and the webhook itself works by setting up the FME server to expect a specific kind of JSON payload from a specific IP address or URL. So when you do that setup and you tell the survey 1 to 3 app that we need to send that webhook to this address, you define that on both parties, the survey app and the FME server itself. You define the addresses, the webhook, the JSON payload format, and everything, so that when the JSON payload is sent using HTTP or using a post request or a HTTP request, the FME server will trigger the workflow for data analysis. So that's how the webhook works here. If you wanna, do you wanna see how this is set up on survey 1-3?
No, I think you answered my question. Essentially saying the webhook is issued after the completion of written, the survey 1 to 3 payload gets written to the ArcGIS server.
About validation.
So I think that's the important aspect. As long as you do that, I think it should be consistent. Yeah. Yes.
So regarding validation, we do all validation on the interface itself, the survey app. The answered values, the non-answered values, the contradicting values, and everything, we do that on that level.
Okay, good. Thanks.
Sure.
So I will say from my experience of doing this, one of the biggest things that I ran into was potentially a survey not being submitted, being triggering the webhook, or FME server having some sort of problem or whatever. And the way that I got around that was just to have your webhook stuff set up and then have a secondary process. If they know the object ID, you can put the object ID in and re-trigger the workspace to run.
So I need to make sure I understood that right. So if the webhook failed to trigger, there is
so the webhook always triggers, but on the FME server side, if let's say it like there are instances where it would like get stuck in the queue, or the queue built up and you just like or you cleared like all the jobs in the queue, so the the queue would be able to start running jobs and stuff. Or if the job got stuck running, you had to cancel it. A secondary process where you would basically put the object ID in, and then it would use the, I guess for the most part, the rest of the process to do the same sort of output.
And this alternative path is set up on the FME server itself.
Yeah. I am curious. I'm doing some stuff with the traffic signal people as well. What other are you doing? Is this the only thing that you guys are doing with them, or?
I'm sorry, we're doing what?
With the traffic signal lab.
Yes, no, not the signals lab, the traffic signals team in the CTDOT, but we are developing a new app now for maintenance level change, which will be the traffic signals lab will be involved in the process, the approval process. So they will receive the survey link and will put their input.
Okay, cool. And then is this built on your guys's, or I should say the Connecticut DOT's infrastructure, or is it like your organization's? I guess, are you one and part of the same?
So we developed this workflow in the CTSRC, Connecticut Transportation Safety Research Center. It's part of UConn,
Okay,
and we are partnering with CTDOT.
okay, so this is implemented on their environment.
Yeah.
Okay,
This is Eric. I got a couple questions, maybe not completely FME related, but it's about the workflow you have here. What role does the as-built play in the process that you talked earlier? You mentioned that there's an as-built created. I'm under the assumption that FME doesn't do anything with that as-built.
No. So originally the traffic signals team used to part out this as-built document to Excel sheet and use formulas to calculate wattage values, which was very time consuming.
Yeah.
But currently they do that through the survey app. There is like interactive questions. It makes the process way easier,
Right.
and automatically calculates wattage values and then submit the data to the ArcSD database.
Okay. Okay. Perfect. And then on the PDF that's output, what becomes of that? Where does that go? And when is that generated?
So so according to the workflow here, it only generates if the let me bring that.
I think it was toward the end of your slides.
Let me bring the whole image. So it's the PDF is generated only if the power letter at this stage where the power letter was sent. So sorry, if it wasn't sent. So we developed that a while ago. So to answer your question, the PDF is not automatically generated, but at some step on the power letter review, there is a link on the survey app that goes directly to the feature reports interface and generates the PDF. Then the engineer will attach it to the survey itself.
Okay, very good. Yep.
Yeah.
Thanks.
So we ask it for. I think it's an open question now to provide some link that automatically generates the report, but currently Esri or the ArcGIS team only have this way to generate reports through the reporting interface.
Okay. I also want to compliment you on documenting your workspace. Very good.
Thank you.
Yeah, it's always important.
It is.
So, do we have other questions, comments from the audience out here?
for the,
I'm following up on the FME generation process. Is that process generated by another FME workspace, or is it something Esri through Esri stack or generate outside the system?
No, well, the FME has nothing to do with Esri. It's like a cross-platform interface. It uses webhooks to trigger any process you want. And there are many apps out there that can create webhooks. Survey123 is one of them. There is another platform that's more, I would say, easier than FME, has less detailed workflows. It's called Power Automate. It can also be triggered using Survey123. So basically, any interface or any web interface that you have that can trigger webhook, you can use it with FME.
So I was just
FME is not Esri related.
I was asking for the PDF generation. Is that as part of the process by part of FME workflow, or is outside? It was part of the Survey123?
No, it's not part of the FME workflow. It's done manually using by the user at the survey interface.
Okay.
So yeah, they go to the reporting interface, generate the report, and attach the report to the survey.
Okay, I see. Thanks.
Thank you.
So the whole process, it uses, like on the front end, all the users go through the survey 1, 2, 3, right? So like you have your people that do the collection, and then it circles back and they do the, I guess with other additional approvals and stuff.
So I can show you a quick overview of the process, how it works.
So I guess I had a couple of questions too while you pull it up. So the FME process, that gets triggered every time that someone does an edit. So every time basically an approval is ran through, right?
Yeah, it gets triggered every time a power letter is submitted or edited.
Okay.
So, and at the FME workflow, I check for whether it's an edit or a new submission and then go from there.
Okay. But the users, they only see the survey 1, 2, 3 front end, right?
Yes. So this is the ArcGIS dashboard, operations dashboard. So from there, they can select the intersection through the map or through the list here, and they can use this to navigate to the survey to generate a new power letter for that intersection. And on the survey interface here, they fill all the information related to the intersection, the customer, the power supplying company, and even the detection load components, the signal heads, how many signal heads, what kinds of lights, what kinds of bulbs, and all this information, and then submit the survey. And from here, the FME workflow triggers and may send out an email, may not, based on the answers of this survey. Also, submitted surveys show up on the dashboard here, on this part, so they can use this list to edit existing surveys. It will open the same survey interface with the information pre-filled. And
so how do you get the I was going to say, how do you get the geometry for that? That's on the dashboard.
Well, all Esri apps are spatial aware, so
Well, it looks like you had the point, but then you also had a polygon.
how did I get the geometry?
Yeah, is that manually
dashboard?
drawn? Yeah.
So the operations dashboard enables you to host different items on the portal. This is a web map. So
I guess I'm asking where the geometry comes from for the intersections.
It's stored in ArcSD database.
Okay.
That's-
So it's
Yeah.
already created.
We have a different contract out through CTSRC where they have
Okay.
undergrad interns drawing the geometry for us.
Okay.
Yeah, Jenny answered that better than me.
Yeah. Sorry, I was on another call. I hopped back on just now.
Really neat system. Pretty useful.
I can't hear you very well.
I think that's it's a very good system in combining many different pieces of technology. I think FME over here plays one role, adding the automation piece of that, which I would think is more difficult to implement without, if we're purely
it's very useful here.
Esri stack.
Yeah, it covered many of the limitations of Esri system here.
Do you guys factor in the different like phases and stuff, or is it just a standardized based on like the number of heads?
Different phases.
Yeah.
Yes, actually, this information is designed with the survey. So here, when you add signal heads, you tell it how many signals and the number of phases here. And for each signal, you decide you will pick
Oh.
at each phase what kind of signal is on and off. For example, phase 1 is arrow, phase 2 is red arrow, phase 3, phase 4, and so on. And that's for the green wall signals too. So if the first 2 phases red and the second 2 phases are green or the opposite, so that's how it works.
And then I assume they're labeled. This, or I guess, yeah, obviously it labeled the signal heads. Is there, so I know looking at some of the as-builts and stuff, is there a method to go from like, or easy method to go from like the as-builts to this?
Well, the as-builts, I'm not sure they are well formatted to automate the process, but
Because I know they have the phase, like all the phase information on them, and I mean basically all this, with I suppose the exception of like, I guess they even have detectors, a number of detectors anyway on there as well.
yeah. So yeah, there is another section here to add the detection load components, number of components, the type of components, and
Cool.
other, yeah.
So is this something that you guys are doing, I guess, as being contracted by Connecticut, or is this something that, well, that you're doing right now to get it at least started, and then eventually like they would take it over and or be like a requirement that contractors do?
The automation process itself.
No, like the entering of the data.
So I could grab that one, Motaz. So CTSRC was contracted out to develop this more like a contractor, and then Aaron Nash, who hopped on the call a little later, he, I believe, will be working with the signals team to help train them on the application. So the maintenance guys will go in the field, and when they're doing their inventory, they will start to fill out this form to complete a whole list of where everything's at.
Cool. I think there's a lot of potential in something like this, and I know we're working with Connecticut, and so Eric and I are from Iowa, and at the Iowa level, the state doesn't own any signals. It's all mainly, I think, cities, and obviously with Connecticut, it's pretty much at the state has them all, but the cities and counties and whoever else helps with the power side of things, and or owns them or maintains them.
Yeah, I'm not as familiar with the process because I don't work with the signal teams directly, but it's a little more unique here than I know some of, especially the larger states. Although everyone's pretty large compared to Connecticut.
So the stakeholders in this are mainly going to be at the state level, correct? Or are there also going to be like stakeholders at the local level that, for instance, get like the power app bill or whatever?
So predominantly the state level. I'm not sure what the plans are would be for more localized information, and you do know that as some of this information comes in, it will be getting vetted to eventually, some point down the line, go to our open data portal.
Cool.
Any other questions? Well, thank you, Motaz, for presenting. It was amazing as always.
Thank you,
And
Jenny.
Yeah, thank you.
if you want to
was
drop
real
your
good.
email in the chat, so if anyone wants to follow up, they can reach you. That would be awesome. And I want to thank everyone for joining in today. I hope you all enjoyed enjoyed it, and we'll have more fun things to come at the next meeting.
Thank you.
Thank you. Well done.
Yeah.
Thank you. Appreciate it.